Ladies and gentlemen, good afternoon and welcome to the fifth episode of the series of webinar Space for Twin City dedicated today to smart mobility. I'm Donatella Ponziani, ESA Downstream Gateway Officer, and I have the pleasure to introduce this webinar today, gathering together representative of the municipalities of Turin in Italy and Tallinn in Estonia, debating together with ESA experts. I don't want to take the floor for too long, and I would like to introduce to you the moderator for this session, my colleague, Nick Appleyard. Nick is the head of the Downstream Business Application in ESA. He joined ESA in 2016. He had a huge and long experience in innovation and business development, holding several positions in UK government agencies. He holds a PhD in physics and today gave us the honor to be the moderator. Nick, the floor is yours.
Well, thank you, Donatella, and it is an honor, and I have to say a pleasure, to moderate this session. So our topic for today, in the context of cities, is smart mobility, and I have the pleasure to be the moderator of four excellent speakers who we will hear from in a few minutes. And this is an area where European Space Agency is taking a great interest, because we see the power of the connectivity and the data and information services which can be powered by satellites, really connecting to people on the ground in their day-to-day activities and their businesses. And we try to make that connection into the priorities that users and customers have as they try to improve, in this case, the logistics and the mobility situation that they're faced with. And we find that all areas of the satellite capability are relevant on this. So in my own area, I work within the Directorate of Telecommunications and Integrated Applications. And certainly these connectivity questions keep coming through as the connectivity on the ground evolves and mobile connectivity improves. So we've moved to 5G and soon 6G. There is a satellite component which contributes to this, which allows us to remain connected to vehicles as they move around on the ground. Equally, the Earth observation capability that we have from satellite images and sensing tells us what is happening around those vehicles and around the people as they move around. And then the location technology allows us to track the movement. So all of these things come together into an integrated technological system. And there is no better place really to examine that than in the context of a city. So I'm very happy to have with us two speakers who represent two cities from the north and the south of Europe. Who will share with us their experiences, and then two of my own colleagues from the European Space Agency who will talk to us about the different roles that satellites play within that. So if I may just briefly introduce our four speakers for this afternoon. First, Fabrizio Fabricio, who is the Chief Information and Technology Officer from the company T5 SOL in Torino. We have Jakob Enselu, who is the head of smart mobility projects for the transport department in the municipality of Tallinn in Estonia. And then quickly we jump across two time zones to Amanda Regan, who is the head of the Phi Lab and the InCubed program for Earth observation in the European Space Agency, and Javier Ventura Traverset, who is the head of the ESA Galileo Navigation Science Office. So we represent all the different parts of satellite capabilities here, and we represent all of the different modalities and different use areas across Europe. So our first speaker then is Javier. Our first speaker is Fabrizio Fabricio. So he's the Chief Technology Officer of 5T SRL, and this is his work concerns intelligent transport systems and the ICT solutions which enable mobility services in the context of the city of Torino. This encompasses technology strategy, supply chain management, production tracking, and really trying to pull together that whole story of how smart mobility acts within the city. So, Fabrizio, if I can ask you to address the question, give us a little overview on smart mobility projects which are happening within the municipality of Turin. Thank you.
Yeah, thank you, Nick, for giving me the floor, and I would thank ESA for the invitation, giving us the chance to share what we are currently doing in the Turin city. As mentioned, I'm the CTO of 5T, that is the technological in-house company of the Turin city, dealing with the provision of ITS-enabled services. Basically, we work on traffic management and control, on smart ticketing. We work on infomobility services and on mobility management. As far as this evening webinar is concerned, I'm focusing and sharing my presentation on what Turin City is currently doing on smart mobility. Of course, smart mobility is an umbrella of terminology and services and technology aspects. So 7 minutes, of course, are not enough to describe all of these aspects, but mainly I will share with you what we are currently doing, what is our experience on that. And as far as mass mobility is concerned, basically, the Turin City during the last couple of years is concentrating the effort on the so-called ITS cooperative services. Basically, we are talking about services and technologies integrated in order to provide standardized cooperative services called Day 1 and Day 1.5 in Europe, basically towards the so-called connected vehicle or vehicle with autonomous vehicles. With the main purpose to tackle infomobility and, of course, first of all, I would say safety purposes. And this is the aspect, the interest of the municipality to improve the safety in the Turin city, in the municipality territory, and also to give more and precise information about mobility to the passengers, to the drivers, and so forth, to the users in general of the mobility services. In Turin City, we have a traffic management center based in our company. This traffic management center, of course, deal with several services. But as far as cooperative ones are concerned, the TMC is mainly devoted to distribute so-called standard messages, standardized by ETSI, towards in general to the devices enabled to receive and elaborate those messages, but in particular devices on board of cars that moving around in the Turin, on the roads, on the urban roads, are able to catch these messages through cellular or long distance connectivity or through short range communication, like for example ITS G5, exactly to enable these cooperative services. But what are we exactly talking about? What are these kind of cooperative services? If you move towards the next slide, we can see basically inside Turin the creation of the dedicated area, dedicated path, where we basically invite stakeholders that could be, companies, telcos, startups, to test. This is a pilot area to test this kind of services, like, for example, the GLOSA, the Green Light Optimization Speed Advice, that is the service that suggests on board the vehicles which speed maintained in order to catch the green cycle, or to provide information about the residual read time, and also support the safety, as I mentioned before, on the road, in particular communicating onboard the vehicles the case of let me say the risky cases. For example, if we have a road, an intersection with a dedicated cycle lane, if the bicycle is approaching, this generate an alert, a warning that is visualized on the device and suggested to the driver to reduce the speed or to be careful about the fact that a different vehicle is moving. Coming back to this pilot area, I think this could be quite interesting for the auditors, for the audience. Basically, as I mentioned, we are concentrating here a lot of technology like traffic light assistant enabled traffic lights. That means basically to have traffic lights enabled to communicate the signaling and the duration of the cycles or the other kind of stuff to connected vehicles in order to improve, to enable the services I mentioned before. In the next slide, we can see the fact that the approach we are following is a standardized approach and came in particular from the so-called C-Roads platform. It is the platform created by the European Commission, and this is the place where basically is guaranteed the uniform deployments of this kind of services, of these CITS services in the European member states countries. And also in this place there is a common work to create and to agree on technical specification, in particular using and reusing what has been already done in the dedicated standardization body, like in particular ETSI, but not only. All this experience moving forward is basically used in order to also gather a lot of data that can be used to elaborate the policy and to improve the governance. As we can see in the next slide, this rich and huge amount of data can be used again from one side to improve, as I mentioned, the governance of the municipality in order to improve the sustainable mobility plans, urban mobility plans, but also to tackle the several delegated acts, in particular the 1976, that is the delegated acts that require to the member states to create a national access point for interoperability, and in particular for the exchange of mobility data among member states, but also, I would say, inside the member states among stakeholders. And this is the case of Italy, and in particular of the Turin City and the Piedmont region, where we basically exchange mobility data, considering huge amount of mobility data, not only for traffic, but also for public transport, from the city to the ministry, to the national access point, using also in this case a standardized approach, and in particular the delegated acts require to use the DETEX2 dedicated protocol for traffic data information exchange, and NETEX and SIRI for the public transport one. So these together, the policy and the governance of the municipality of Turin is are the means to that the Turin City put in place also with particular attention, to the innovation aspects, soliciting, as I mentioned when I described the pilot area, soliciting also and attracting companies and startups, and also, of course, a university, in order to, again, improve and put in place an improvement process to increase safety in the mobility and to enhance the, let me say, mobility services portfolio available in the Turing city, in particular in the framework of the so-called MaaS approach, the mobility as a service approach. Okay, I would stop here to trying to respect the given time, and again, thank you for your attention.
Well, thank you, Fabrizio. And can I say that European Space Agency is finding it a pleasure to work with the municipality in Torino to bring some businesses towards these problems and these user requirements which are being identified by the municipality, and it's been very good working together. Very good. Let's we speak now about twin cities in this broadcast. So, in order to twin against Torino, we now turn to Tallinn. Now, I can introduce Jakob Ainsalu, who's the head of smart mobility projects in the transport department in the municipality of Tallinn. Now, Tallinn has an extra dimension to all of this, being a coastal city. So the mobility solutions also are not only on the roads, but also are up to the coast. And let's hear from you a little about the journey that the municipality of Tallinn is taking towards smart mobility. So, Jakob.
Thank you for this introduction, and thank you for the opportunity to be here. So I will do my best, because I have only 7 minutes, so I will go now on with my presentation. So hello everybody, my name is Jakob Ainsalu. I work City of Tallinn Transport Department, and basically I'm the head of the smart mobility, different kind of projects and different kind of movements. So maybe just a brief introduction where the Estonia and Tallinn is. Tallinn is the capital of the Estonian. We have about 400,040 inhabitants. It's located in northern eastern part of Europe. We have 3 rivers, 2 lakes, 1 island. It belongs to Tallinn. Yeah, we can go now on. Next slide. And if today's topic is the smart mobility and mobility, so I will show a little bit the big scale for the future Tallinn. So the Tallinn is the only capital in Europe where the international airport and harbor and international railway stations are within 5 kilometers radius. So it means that we have very close distance. We have chosen the Hyperloop 1 Tallinn to Helsinki, Finland connection as one of the prospective routes. We have doing with our government and the Hyperloop 1 company one of the agreement. We are also planning to do the Rail Baltica. It's the new international railway to Europe, and it will be start from Tallinn. So it gives us very good connections the middle of the Europe. Also, we are planning right now to digging the tunnel between the Baltic Sea, Helsinki and Tallinn, because nowadays during the COVID-19 crisis, the movement between Tallinn and Helsinki has going down, but last year it was 9 million passengers between Tallinn and Helsinki in 1 year. So a lot of the Estonian people is working in Helsinki side, and and Helsinki side is coming to Estonia and Tallinn to take a holiday, and also the Chinese tourists came to Helsinki and also came to Tallinn. So it's it's a quite impressive movement between two cities. So, and we have quite many self-driving bus projects already done, and we have built our own self-driving bus with cooperation with our technical university. So yeah, now we can go on. What we have done in public transport side is that, as you see in the picture, that traffic congestions are basically in every city, and we have been trying to do the priority lanes for the public transportation and giving the green lights for the district. So as you see in the picture, it's one of our Pirita Road. And it's quite heavily private car users, but we have built basically just only the transport lane for there. So it means that the bus can go very, very fast for this road. Yeah, and we can go on now. And also what we have done is that we have this park and ride system. That means that you can leave your car in park and ride park, and then you can take the public transport. As maybe you don't know, but the public transport for the citizens in Tallinn is free. So what we have done is that those people who's coming outside the city, then they can leave their car in park and ride park and take the public transportation also free, because the parking fee in Tallinn is one of the expensive in Europe. It means that we have city center, we have €7 per 1 hour. And this year we're planning to integrate the micro mobility also in park and ride system. So it means that you can take the electrical scooter and electrical bicycle also. Okay, we can go on now. What we have is also that we have this electric car short-term rent, that you can take the electric car wherever you want. It's basically just a mobile phone app. It's a key-free. You just need to sell a phone to rent. We have 31 environmentally friendly electric and hybrid vehicles. We have these rental points in Tallinn and Tartu, and it costs around 4 to 6 per hour, and also we have 29 electrical charging station, open charging station. So you can just go and just charge your electric car. Okay, we can go on now. As I mentioned before, that we have done not quite many, but actually 3 or 4 self-driving bus projects. As you see, this one of the Navia bus, it was driving in this year and last year in Kadriorg. It was very popular, and the black one is our invented self-driving bus with cooperation in Tallinn Technical University. So and in this year or next year, 2021, we are also going further with the self-driving bus projects, and we are taking out the operator also these buses. So it means that we're going to the next step. Okay, we can go on now. Just maybe briefly overview that we have these partially delivery robots also in Tallinn, and it's also legally in the streets since 2017. Self-driving cars and buses are legally allowed on streets in 2016, and ride sharing is also legalized. So it means that it's 2017. And if you see this IT card in a one-man hand, it means that basically everybody can order the Estonian IT card, and you can establish and build your company in here. So it's quite easy. So everybody, please free to try. Okay, we can go on. Yeah, this is just normal picture for the partially delivering robots in Starship robots. It's a normal for our streets to understand that. I'm not joking but these kind of robots are really driving in our streets. Okay, we can go on. And also one of the last thing is that we are also using and piloting the artificial intelligence for our smart mobility in Tallinn. So it means that we have district open cameras, and we are calculating the cars or every movements basically for the artificial intelligence. So it means that artificial intelligence is calculating every cars, bicycle, human, and then we can do the calculating to do the green lights, green corridors, or whatever. So okay, we can go on. Yeah, so I think my time is also over, and thank you for this opportunity. And if you want something more, then please free to contact me. Thank you.
Well, thank you, Jakob. And I have to say that over many years we've been watching Estonia and the progressive attitude towards digital government, and now really turning this into a physical ambition in the streets towards early adoption of technology. It's showing the way, I think, the way forward for many of us. We'll all be following. Let's hear from some of the European Space Agency experts a little about the contribution which space can make to these environments and these user requirements that we've heard in the municipalities. So first we'll call upon Amanda Regan. So Amanda has a long career within the European Space Agency, working on future missions for Earth observation, and also has spent some time in the European Commission similarly. And now heads the FELAB Invest office, looking for the future technology developments and the entrepreneurial environment for Earth observation, and the support program InCubed, which stands for Investing in Industrial Innovation. Where she's the program manager. So Amanda, can you tell us a little bit about then how European smart mobility can be fostered through ESA and through the Earth observation programs which you lead?
Yes, I hope that my presentation will be able to answer that. I don't actually see the slides, so I will look at my own version. They've just come up. Okay, perfect. Okay, so I'm just going to give you a whistle-stop tour of what we're doing in the ESA FELAB and also in the InCubed program. I work in Earth observation, and we are standing in the middle of a perfect storm in Earth observation right now, which is unprecedented. And I just want to give you a kind of a flavor of the kind of landscape that we're operating in. And we really see things like smart mobility to be an integral part of this. So we have more Earth observation data than ever before. We have Copernicus data providing long-term systematic data. We have major technological advances. So we have the performance of Earth observation satellites is just exploding if you look at how things were maybe 20 years ago. And things from the ICT sector, the information technology, are also crashing into the Earth observation domain. So we have things like cloud computing, artificial intelligence, machine learning. All of these things are allowing for internet or like a connected thinking, if you like, which again, we didn't have 20 years ago. If you can actually imagine, we have a generation now of people that don't know life without the internet. So there's a certain trust of distributed systems over centralized systems that, again, we didn't have a generation ago. So there is a certain trust in the crowd. And that, coupled with technological advances, I think we're in a really special time. We're also seeing that access to space and access to space data is also becoming so much cheaper and easier. And this is really attracting new commercial players and new investment into the sector and a new kind of entrepreneurial spirit. So allowing for economies of scale, constellations, and things that you can do now with Earth observation satellites that you couldn't do before. Next slide, please. So what we're doing from the Earth observation point of view is, if you can go back one slide, please, we're actually moving from images and data sets, because that's really historically what Earth observation satellites were all about, to actually using this technology and actually developing into intelligent decision making and commoditized intelligence. Next slide, please. And so we're actually moving from Earth observation, which is rather a passive term, to Earth intelligence or Earth analytics, if you like. And I think that smart mobility can be really part of this new exciting paradigm. Next slide, please. So we have recently set up a new ESA Phi Lab, and the idea of the lab is really to focus on transformational innovation. And we're wanting to go from real blue skies research up to try and supporting and developing European competitiveness. And we're establishing a pathway through the lab, looking at research concepts, then going to prototypes and user cases, developing the concept, and then starting to look at the commercial viability of these things. Next slide, please. And so the lab comprises two offices. On the one side, we have the Explore office, looking at connecting the sensor revolution with the digital revolution. So they're looking particularly at artificial intelligence, collecting all of this data, machine learning and distributed systems. And then on the other side is the office that I'm looking after, which is really looking at fostering entrepreneurial activities through the InCubed program. Thank you. Next slide. So this is our Phi Lab innovation model, moving from left to right. And I won't go into too much detail, but you can kind of see how we're wanting to move from research and also prototyping out to disruptive technologies and commercial innovation. Next slide, please. And here's just a few of the lab successes. I think the main message of this slide is please come and work with us. We are involved in satellites that are being powered by artificial intelligence. We launched the first ESA satellite in September, and we have a lot of visiting industrial and also academic people that come and spend some time in the lab because we're focusing very much on artificial intelligence, etc. Next slide, please. So this is the kind of things that we're working on. We're really looking at developing, for example, the white paper for artificial intelligence, augmented analytics, blockchain, digital twin is something as well that we're looking at, as well as quantum computing, and also basically trying to develop use cases and prototypes in this area for Earth observation. Next slide, please. And we're very much at the moment focusing on artificial intelligence and how we can bring Earth observation from provision of the single images to intelligence. Okay, thank you. Next slide. And here's just some examples. So with the German Space Agency, for example, we've been using Earth observation data looking at human settlements, surface mapping, looking at different building heights, for example, and also population distribution. It's not directly smart mobility, but you can see that this is all part of a bigger system that we're looking at and trying to work with different programs and different actors to be able to answer these big questions. Also things like infrastructure monitoring, also looking at the atmosphere as well as another key thing, and using different kinds of Earth observation data as well for object detection and also infrastructure monitoring. Next slide, please. So I just wanted to spend one slide giving you an overview of InCubed. As Nick said, this is the Investing in Industrial Innovation Program, so it's InCubed. And this is really one of the first Earth observation co-funded programs that has been put together at ESA. And its aim is really to support and develop the commercial EO sector based on Earth observation products and services. And it's a co-funded activity, a PPP. So companies, and that can be startups, small companies, large companies, they have to put a little bit of money on the table or skin in the game, if you like. And we're wanting to basically de-risk their commercial developments. We're looking for innovative and commercially viable EO products and services, and we have a really wide scope. So I know today we're looking very much at the analytics, but in InCubed we also fund and we help build satellites, as well as data platforms, data analytics, and also innovative business models. And what we want to do is basically have at the end at least a minimum viable product that you can de-risk your development and showcase this to further commercial customers or indeed potential investors. And if you want some more details, you can go to our website. And also, if you want to know our onboarding process, you can have a look at ideas.esa.int. Okay, next slide, please. So this is my last slide. It just gives you a flavor of the kind of activities that we have in InCubed. We would very much like more activities related to smart mobility, which is why I was eager to join this webinar to basically call out for people that would like to come and work with us. We already have some activities that are related to infrastructure monitoring and also various monitoring of different kind of Earth observation features. But that's it. If you're interested, please contact me and let's work together. Thank you.
Thank you, Amanda. And I should say how powerful it is seeing how when we put this really very advanced and rapidly developing technology into the hands of entrepreneurs, the ideas that they come up with and the impact that can have. And we work across ESA, but with my own area, which is, if you will, the business end, the demand side end, in a strong collaboration to bring the technology and business together seamlessly around this. So thank you, Amanda, for that. Let's turn now to our fourth and last speaker in the rotation. This is Dr. Javier Ventura Travasat. Now, Javier has a very long career in ESA and really across all areas of the space program activities. So this includes telecommunication, Earth observation, microgravity, the scientific programs, and now in the navigation program, where he's the executive secretary of the ESA GNSS Scientific Advisory Committee, and also the head of the Galileo Navigation Science Office. So, Javier, could you provide us with a little overview about how Galileo and GNSS capabilities are having an impact on this smart mobility challenge that we face?
So, thank you very much, Nick. A great pleasure being here, and really very pleased to address about satellite navigation and Galileo, which, as you noted, is a major enabler for smart cities in general, and in particular for smart mobility. So if we go to the next slide, when I teach in the university, I normally like to provoke my students with this first slide before we enter into the lengthy equations. But I like to tell them, actually very relevant in the smart mobility, how many cars are in the world and how many satellite navigation receivers are in the world. I ask this question a little bit provocative to tell them and to really illustrate how tremendously important is satellite navigation in our planet. And actually the answer you can see in the next slide, there are 8 billion receivers, approximately, about 8 billion receivers in the world. That's really amazing. For the people who have started GPS many years ago, this was unbelievable. And today Galileo is taking a major share of that, 8 billion receivers, so 6 times more than cars. And actually you can see an average of more than 1 receiver per inhabitant on planet Earth. That's really amazing. Actually, this has a tremendous impact in the economy and also in the cities. And we are talking in the case of the European Union, the estimation is, you can imagine, around 10% of the total GDP of the European Commission, the European Union actually, it is impacted in one way or another on the availability of satellite navigation. And actually that's not surprising if we go to the next slide, just to illustrate that every single sector of the economy, it is actually impacted. To know where you are, to know what time is it with precision, and to be able to share that information is inherent to all the human activities. And another challenge I give to my students is to put me in difficulties, asking me for any economical sector they think navigation has not a linkage, and I always, so far, managed to find a link. Actually, from the obvious transportation, we have the energy sector, agriculture, banking, location-based services, and obviously smart cities and smart mobility. As we go to the next, just to recall that we have, we go to the next slide, the 4 global navigation systems in the world, GPS, Galileo, Beidou, and GLONASS. Simply every single power on the planet Earth wants to have his own system, but it's interesting to know that we are interoperable among ourselves. But I just wanted to now give a little bit more of details on our own system, for which, by the way, we are very proud, the Galileo system. If we go to the next, if you had to summarize Galileo in 4 basic messages, I think I would say that it is really the European system. It is providing a global coverage worldwide, position and navigation. Remarkably, it's under European and civilian control. It is not a military system. It is designed in Europe, controlled in Europe, and provides to Europe independence. That's the single, probably most important reason for why we developed Galileo. And also, very importantly, we have a degree of influence, and we can also define our policies related to that. Despite we have autonomy, we want to be compatible and interoperable with the other systems, notably with GPS, so we can use both together, and this offers also many benefits in cities for smart mobility, improving very much the availability. Galileo, however, has some differentiators, which I will illustrate in some seconds, differentiators which are especially favoring smart mobility and which are not available on the other global navigation systems. And as I mentioned here, allow new services and applications. Just let me tell you a little bit on the Galileo status. If we go to the next slide, Galileo today, we have 26 satellites in orbit. Since we started putting satellites in orbit in 2011. 4 of them are in the family IOB, and 22 are in the family what we call FOC. We are producing 12 more, so which means we will ensure the sustainability of the constellation. We will launch then, starting hopefully from next year with Ariane 6. I just wanted to highlight here one of the critical technologies of our Galileo, obviously, is the clocks, the atomic clocks on board, and we are very proud of the PHM technologies, which allow us to have actually an stability and an accuracy about 1 second in 3 million years. You can imagine, which is 1 billionth of a second in 1 day. If we go to the next slide, please. Galileo started what we call the initial services in 2016. On that time, the constellation was not yet fully deployed, but we started there. And it is really impressive, the impact and the penetration of Galileo and the very fast growth of Galileo penetration. If we go to the next, you can see that in only 34 months, since the moment Galileo started initial services, we reached already 1 billion users. And I really invite the audience to go through the internet and to look for the 1 billion Galileo. There is a video which is very nice, comparing how much time it took to other technologies to reach 1 billion users. For example, talking about cars, it took about 125 years since the first cars to reach 1 billion cars. But even if you think in technologies today, the internet, it took 36 years from 1 user to 1 billion users in internet. Obviously, we have more today. But even Facebook, that you can imagine, the fastest growth, it took like 8.5 years to reach 1 billion. But Galileo did it in only 34 months. Today we have 1.8 billion users, and this is growing. And it is very interesting also to say that there are all the mobile phones today are compatible with Galileo, and there are more than 500 models incorporating Galileo today. If we go to the next slide, what I wanted here is to highlight some of the differentiators of Galileo with respect to the other global navigation systems, which in my opinion make it especially suitable to a smart mobility. You have here those the possibility to have multiple frequencies, transmitting signals in multiple frequencies, so you can eliminate, for example, the error associated to the atmosphere, to the ionosphere, the possibility to provide high accuracy services, and what we call authentication. And let me just dedicate one slide to each. If we go to the next, the multi-frequency, this is illustrated here, a nice qualitative test we did in the ESA stadium we have in Estek, in our facilities in the Netherlands, just with a very rudimentary mobile phone. When we go single frequency and we go twice through the lines, you can see they are not really converging. If we go with a very cheap Galileo dual frequency mobile phone, the situation is much nicer. On the right, you can see that actually with a simple mobile phone today, free of charge, you have accuracies already below 1 meter, on the order of 70, 80 centimeters already today. But this is just the beginning. We are working and we are testing what we call the high accuracy service. If you go to the next slide to illustrate that, we are going to provide with Galileo free, open, of the order of 20 centimeters accuracy. That's really amazing on a regional and on a global level, with some enhancements at regional level in the time to conversions. This is achieved on what we call precise point precision, which allows to have high accuracy of the orbits and of the clocks, allowing, as I mentioned, 20 centimeters. If we go to the next, the third feature I wanted to mention is authentication. Authentication also is a unique feature which Galileo will introduce very soon. And this is the ability of the system to inform the user that he's actually using Galileo and not another. And this is really helping to mitigate vulnerabilities, making satellite navigation secure, but also making satellite navigation to be used for secure applications. This is really fantastic. So I go to the next slide, which is the last one, simply to highlight this combination of Galileo with the other systems, but especially the features I mentioned on Galileo, authentication, dual frequency, and the high accuracy services are a major enabler for smart cities, and you see examples here on smart mobility, smart parking, geofencing, smart lighting, autonomous transportation, real monitoring of noise and pollution, etc., etc. So we are convinced Galileo is a key player. It is our system in Europe. We can define policies with our system, and with enhancements ongoing, I am convinced this will be a major breakthrough. Thank you very much, Nick.
Thanks, Javier. And I have to say, when we analyze the markets around space and we see where the investments are going, really it is maybe not the things that people expect, but the largest financial commitment being made to space is in two areas. It's in digital services, which are making use of the satellites, as we've just been hearing from both of you, and the ground equipment. To connect 1 billion users into these systems is a large investment in equipment. And if you want to get into big business in space right now, then these are the areas where the investment is going in large volumes. In future, well, we shall see. Let's see how this develops. If I can then call together all of the speakers to congregate and thank them all for their presentations. And we'll close out our proceedings just with a few questions around to them as a panel. So a question to everybody, really. So based on what we've achieved so far in smart mobility, what are the next steps? What are the things we need to do to boost this and take it forwards for the next generation of services? And if we can stay in the same order that in which you presented, so we start with Fabrizio, if you would. Thank you.
Yes, Nick, thank you. In Turin, we would move towards increasing digitalization, and so improving and enhancing smart mobility, mainly in two directions, in the direction of to improve the safety, and in direction to improve the sustainability. I mean, with safety, so giving the chance to, as much as possible, citizens to move from point A to point B in a safer way, and in this case, services like advising for risky situation or impedance on the roads are some examples of services that can move in this direction. The second one is for the digitalization of these services, and to improve, as I mentioned, the sustainability, because in general for urban territory, but in particular for my city, the sustainability and the pollution and all the effects of the traffic and the mobility, the side effects, is something that must be tackled. And concerning this, we are, for example, experimenting the control of vehicles in the limited traffic zone according to the kind of the engine used. I mean, for hybrid, for example, for hybrid and connected vehicles, they can enter limited traffic zone if they switch from internal thermic engine to the electric one. This is not a service in operation, but is experimentation that we are that currently is in progress in Turin, together with the FCA, and is based on the communication with our traffic control center that enable or disable the permission to enter limited traffic zone, as I mentioned, according to the use of the engine.
Okay, thank you. And if we can then turn to Jakob, so digital transformation, digitalization, and hybridization of these systems, is it the same story for you in Tallinn? Is this how this is moving forward?
Yeah, definitely, because we have seen that this artificial intelligent and self-driving buses and different kind of like future things are helping our citizens, and as you understood what are the needs of your city, then also you understood what kind of future transportation you need, and I'm saying that to encourage everybody that it's not easier maybe in the beginning, but after first pilot it's going also easier, and the key word is the like cooperation between different kind of state department and different kind of organization, and yeah, I have to say the digitalization is helping a lot, and do not be afraid to use that.
Yes, indeed. So, okay, then this is then the challenge from the ground. Amanda, how will we respond? How are we taking the technology forward to respond to these needs?
Yeah, I mean, the way that we actually design satellites and the resulting products and services, we always looking at the customer and the user needs, as Jakob said. And the problem with user needs is that people don't know what they don't know until they don't know it. So there's a little bit of a circular thing there. I think what we have to do from a satellite point of view is we have traditionally just had single satellites flying around doing their thing. And I think with the onset of digitalization and all the things that I spoke about before, we can actually produce a network. So satellites become a node in an overall information network. And so connecting the dots, if you like, I think is the only way that we can actually get smart mobility on a consistent basis. And so you can have things like looking at motion, looking at how the roads are moving in terms of up and down and side to side, for example, in different kinds of weather or different kinds of tectonic situations. But also you can connect it to things like measuring air quality and all of this kind of thing. So I think whatever we actually start to look at, it also has to be accessible and affordable. So yes, that's what I would say.
Thank you. And Javier, from the navigation point of view.
Yeah, Nick, actually, well, the first thing I would do is certainly to accelerate these differentiators that they are operational. I mentioned the authentication and the high accuracy service. The same that happened with Galileo. I am convinced this will have an immediate adoption and will change a lot the paradigm in the smart mobility. In the case of Europe, we are working already on the second generation of Galileo, so with a tremendous dialogue with the user communities. This is done by the GSA agency and by the Commission, and ESA is in charge of actually implementing. So we are in continuous dialogue to further improve the performances for the benefit of the users. I think the merging of technologies also we are assessing in detail. The combination, for example, of GNSS Galileo technology with 5G, the combination of GNSS technology with artificial intelligence, with inertial systems. And finally, I would mention, it was mentioned by Fabrizio, we are also intending to provide a layer of integrity to the location base. We are doing that today with aviation, with the ERNOS system. So we are talking about what is called ERNOS Next. And the idea is to provide an integrity layer also for the smart mobility, which could facilitate many applications like automatic guidance, for example. All those are in the agenda today.
Yes, and if I can complement this a little from a telecommunications perspective, if we're talking about autonomy of vehicles and so on, the key requirements are that the connectivity should be reliable and ubiquitous. It should be available everywhere, and that it should be secure. And so these are the priorities that we're working towards in telecommunication. And the boundaries between telecommunication and navigation, the boundaries between navigation and Earth observation with the artificial intelligence data processing, these boundaries are melting away, and we're talking about integrated systems across all of the problem space. Coming back to the municipalities then, I think it's a question we should always ask ourselves whenever we're on a technology development journey. Why are we doing it? What are the benefits then of this digital transformation and this new connectivity and services in your cities? So perhaps to Fabrizio first, and then to Jakob.
Well, beneficial is to improve to give the chance to increase the integration among the legacy and the new innovative technologies. This is our experience. Since we are dealing with this intelligent transportation system since more than 20 years, of course, we have also legacy technology with the legacy connection, and now we are enhancing that connection, that connectivity. And of course, this is step by step always more important to have the chance to connect in order to provide, more sophisticated and ad personam services. In particular, for what we are currently working on, that is the implementation, deployment of a mobility as a service framework. So the chance to choose the best way to move from point A to point B, according to, of course, my expectation, but also according to the particular moment when I'm requiring to the system my needs of movement.
Yeah, thank you. And Jakob? Sorry, we'll pass on. Just to close then, question then for our ESA contributors. We haven't spoken so much about the very heavy investments which the European Union is making into this in terms of the Copernicus program and Earth observation, and also we heard a little about the Galileo program. As these move forward in their next generations, how is this creating a European capability? What are the possibilities for those which will emerge in the next generations? Amanda first, and then across to Javier.
Yeah, so we have a number of high priority candidate missions already in within our department that are being developed at the moment. There are things like thermal infrared, etc., and many other different aspects. I think that we underestimate how good these long-term systematic data provision systems actually are. I mean, Copernicus is a free and open system, and I think that we're seeing, particularly in InCube, quite a number of companies that are relocating from non-European states just to be inside Europe, because they're seeing that this is where Earth observation is at the moment. So I think that in order to move forward and have a second generation Copernicus, we need to continue this momentum.
And Javier, the last thought from yourself?
Yeah, simply to conclude, as I mentioned, the agenda now is already fully booked for this decade. We are already the decisions to quickly complete the constellation, but at the same time quickly deploy the Galileo second generation. The Galileo second generation will have fantastic features, new features. I think will allow Europe to define new policies. Because we have their own system, the system is ours, we can define policies. And we show, for example, when the Commission defined policies, for example, for the eCall or 112, the penetration of those technologies is fantastic. So I mentioned already these ideas of having liability to the Galileo signal, high accuracy services, improve authentication both in the message and in the signal, and really big differentiators with the others. So again, what I like to finish is with Nick with the sentence of Arthur Clarke. I think I am convinced what we will see during this decade will be an advanced technology indistinguishable from magic.
And yes, every generation looks back on the generation previously and shows them the magic that they've created. Absolutely, Jakob. Let us give the floor to you for our last speaker contribution. We're reaching our hour now. We're going to have to close shortly, but Jakob, your last thought.
Yes, thank you. I just wanted to say that do not afraid to use the artificial intelligence and self-driving technology, so that it's a simplify your work and citizens are love these kind of things. So just use it, and if you need some help, then I'm feel free to help you. Thank you.
Yes, and I hope that goes for everybody who's been on the broadcast today. We're all here to help. We're all here to move this forward into the future, and we're all quite approachable. So let me now then pass back to our host, Donatella Ponciani. Thank you very much to all of our speakers. I hope you've enjoyed this hour. It's gone past very quickly for me. Donatella, would you like to close the session?
Thank you very much, Nick. We are very short in time, but I would like to take the opportunity to thank you all for having been with us today, for your very interesting presentation, and for depicting the way forward. There will be a rich future, full of nice and challenging projects. Thank you very much to all of you, and thank you to all those who have followed us, as well as the organizer.
Thank you.